when we talk about linear functions, all we're talking about is straight lines. For example, if I were to get a coordinate plane out here, and I'll just show you what a linear function would look like on a graph. If I were to just draw me a straight line here, okay, anything that is a straight line is a linear function, okay? And let me see here if I can get a straight line. Let's get this one. Okay, so this is a linear function, that would be a linear function, and that would be a linear function. So all of these lines that go on forever in both directions are in fact linear. And all it means is to be a straight line. So let's look at some examples here. The first one is determine whether the equations are linear. And I'm back on the other slide. Let me go back to that one and erase some of this stuff. So I got ahead of myself. Standard form of an equation is ax plus by is equal to c. Okay, and this is going to be the form that we're going to be writing these linear equations in. Now, it doesn't necessarily mean that they're going to be always written this way, but we want to rearrange them and actually find out what the a is and find out what the b is, and then find out what the c is. The a will always be with the x, the b will always be with the y, and the c will always just be the number. It's not with any letter by itself. And we'll look at some examples of what a linear function is and isn't here in just right now. Example 1, it says determine whether the equations are linear, and I have one more we're gonna show in just a second. But this one is linear, okay, because it meets the criteria to be able to put it in that ax plus by form. And I'm gonna go ahead and write it ax plus by equals c. Okay, so I'm gonna put this equation in that form, and to do that, I'm just gonna go ahead and add 2x to both sides. Do the opposite. So I have 2x plus y is equal to 5. So in this case, our a is a 2. So a is equal to 2. B is equal to 1, because the 1 is just the understood 1. And then c is equal to 5. So if I can rewrite an equation and get it in this form, right here, if I can get it in this form, then that means it is linear. Okay? Examples of equations that are not linear. One like this, y is equal to x squared. Not linear because it has 2 on the x. Okay? Change colors here. Another one that would be not linear would be xy plus x equals 7. Okay, this one is not linear because I have to have coefficients or the variables by themselves. Okay, they can't be x times y in this case. So this is not even a function. But we're going to talk more about that in the next couple of sections. But this is not linear. So if you see one like this, it says is it linear? It is not linear because I cannot define what a, b, and c are in this case because there's no, I can't just rewrite it that way. All right, so let's go on to the next slide here. And a couple of things we're going to talk about are the x-intercepts and the y-intercepts. The x-intercept is simply that. It's where the line crosses the x-axis. Okay, so if I show you a coordinate plane here, okay, and we say where does this line cross the x-axis? Okay, right here, this line would cross the x-axis at 3. Okay, so the x-intercept on this equation would be x equals 3. Okay, so also you'll notice that what is the value of y when it crosses the x-axis? The value of y when it crosses the x-axis is y is equal to 0. Okay, so we can say that the point where the x-intercept is the point 3, 0. Okay, and that'll always be the case. On the x-intercept, the y value will always be 0. Because that's when it crosses the x-axis, the value at any point where it crosses is 0 for y. Okay. Conversely, okay, the y-intercept is when it crosses the y-axis. Okay, and I'm going to draw another line here. Okay, and this one is the y-intercept is roughly -5. Okay, so on this one, y would be -5, the y-intercept. And usually we write that as the y-int, the y-intercept. So the y-intercept is equal to 5. What do you think the value of x is when it crosses the y-axis? Okay, if you're thinking 0, then you would have been correct. So when it crosses the x-axis, the value of y is 0. When it crosses the y-axis, the value of x is 0. Okay, so the definitions of those two would be pretty close to the same. Let me move this out of the way here so we can see. So the x-intercept, the x-coordinate of the point at which the graph of an equation crosses the x-axis. The y-intercept is the same as above but for y. So the y-coordinate of the point at which the graph of the equation crosses the x-axis. So let's look at an example of those. This one says graph the equation y is equal to 1/2 x minus 3 by making a table. So by making a table, I'm just going to make an xy table. And to do that, I'm going to put x, y, and then draw a line. And I'm going to need two values, okay, of this equation to make a straight line. Okay, I'm going to rewrite this equation. 1/2 x minus 3, and then y equals. Okay, so I need exactly two values to draw a line. So I'm going to find two values, the easiest ones, to find what 2 points. Okay, so if I were to put in 0 for x, okay, that means put in 0 right here. It's kind of a messed up arrow. If I put in 0 right there, this whole thing goes away because 1/2 times 0 is nothing. Okay, so y would be -3. If I were to put in a 4 for x, 1/2 of 4 is 2. 2 minus 3 is -1. So now I have the 2 points I need. Now I can do any points because a straight line will have infinite in both directions. So I could put in a 50,000 for x and I would get a corresponding y. Okay, that's the definition of a function, is I'm always going to get a value, for if it's linear. Okay, I could put in 1,000,000 and get a value for y. Put in -1,000,000 and get a corresponding value for y. So let's go ahead and graph these 2 points. 0 and -3, so 0 and then down to -3, which will be right there. And then 4 and 1. So over to 4 on the x, and then -1, which would be right there. Okay, I'm going to see if I can draw a straight enough line. Okay, so my graph looks like that. Okay, it goes through these 2 points, and later on in chapter 7, we're going to talk about the slope of that line. But for right now, just understand this line goes in infinite direction, both directions, and it is straight. Okay, it goes through these 2 points. The y-intercept is -3 in this case because it intercepted the y-axis right there. To find the x-axis, or the x-intercept, not the x-axis, I would want to put in a 0 for y. Okay, because when it crosses the x-axis, the value of y will always be 0. So I would want to put in a 0 for y and then solve for x. So let's do an example of that. If I were to give you an equation, let's say 2x plus 3y is equal to 4. Or let's say 6. Okay, and I want you to find the x-intercept and the y-intercept. First of all, is this equation linear? Yes, it is, because it's written in the form ax plus by is equal to c. A being 2, b being 3, and 6 being c. So my x-intercept is when y is 0. So I'm going to put in a 0 right here. So I would get 2x is equal to 6. So I put in a 0, the 3 times 0 goes away and it's just gone. So x would be equal to 3. Okay, so the x-intercept is equal to 3. The y-intercept is when the x is 0. Okay, when it crosses the y-axis, the value of x is 0. So this goes away and I would be left with 3y is equal to 6. Divide both sides by 3 and y is equal to 2. Okay, so in this lesson we've talked about what a